Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is a Year 1 organic chemistry question. It's a 12-mark multi-part question with lots of different aspects of chemistry involved. Okay, so let's see what we can do. Isooctane, common name for the branch chain hydrocarbons that burns smoothly in car engines. The skeletal formula of isooctane is shown below. Isooctane can be formed together with propene and ethene in a reaction in which one molecule of an alkane that contains 20 carbon atoms is cracked. Now, read this question carefully because it says isooctane can be formed, all right? So you're forming an isooctane together with. So in other words, you're forming a propene and ethene as well as the isooctane, okay? Often students misread this question, right? In a reaction in which one molecule of an alkane, so one molecule of an alkane that contains 20 carbon atoms is cracked. This is not a difficult question. Remember, it's 1 mark, so it can't be that difficult, okay? Using molecular formulas, write an equation for this reaction. You just got to make sure you read the question properly, all right? So we know isooctane is formed, propene is formed, ethene is formed from what? An alkane that contains 20 carbon atoms. So the first thing I need to know is write the formula, molecular formula of an alkane that has 20 carbon atoms. So here we go. So C20, and of course, if you know your GCSE stuff, you would have done general formulas. Okay, so the general formula of an alkane is CnH2n plus 2, just in case you don't know. All right, so an alkane with a 20 carbon atoms is 20 carbon atoms, and how many hydrogens? 42. So that's the first of your conundrums, yeah, first of your problems, working out the formula of an alkane with 20 carbons. And now, so this is cracking, yeah? So you're cracking that alkane to give you these three things, okay? Isooctane, propene, and ethene. Now you might think, oh my God, what's the formula of isooctane? Don't worry, here it is, yeah? So write down the formula because you're forming that. C8H18 plus you get a propene and an ethene. So propene, prop, yeah, 3 carbons, and it's an alkene. So the general formula of that is H2n. So that means 3 2s are 6. Plus, and you get what? An ethene, okay? And of course, another ethene, which is eth, 2 carbons, 2 2s are 4. There you go. And then it says, write an equation. Now, you've got to check whether it's balanced or not, okay? It may be, but let's check. Always check, yeah, whether the equations are balanced. So I need 20 carbons on this side. 8, 9, 10, 11, 12. I don't have 20 carbons, all right? So I've got to balance it, obviously. Yeah, how do I balance it? Well, how can I get 20? Remember, I can't make anything else. These are the only 3 products I get. So I need 20 carbons, 8, 9, 10. Yeah, so I can actually put 5 there. Yeah, so if I put 5 there, 5 2s are 10, all right? And 8, nope, that's not going to give me there. Okay, so I think I probably need to make 12 out of these, 12 carbons out of these to be able to give me, when we add to that, 20. Okay, so how am I going to make 12? Probably, this, you can trial and error, it's not a problem. So if I put 6 of these, if I make 6 carbons from that and 6 carbons from that, that'll give me 12. And of course, when I add it to that, 8, that'll be 20. So how am I going to make 6 carbons? Well, I can't just change that. For God's sake, don't just change that because that's ethene, yeah, 2 carbons. You've got to put a big number in front, balancing number. So this will be, so multiply 3 by 2, that'll be giving me, that'll give me 6. Of course, it's changing the hydrogens as well, but I'm hoping that if I can balance the carbons, it should automatically balance the hydrogens as well. And of course, how do I make 6 here? Well, simple. So if I multiply that by 2, okay, so that's 3 2s are 6. So now that is 6 carbons, that's 6 carbons, that's 12 plus 8, which is 20. And that is your equation. And I'm just going to do a quick check. Okay, you don't need to, but I'm just going to do a quick check with hydrogens. 4 3s are 12, plus 6 2s are 12. 12 plus 12 is 24. 24 plus 18 is 42. That's fine. Okay? Right, simple, innit? Right, let's move on. How do the products of the reaction part C, but remember, that comes through practice, yeah? Practice balancing equations. Right, how do the products of the reaction part C show that the reaction is an example of thermal cracking. Now this is memory work. Yeah, I told you in chemistry, this is why students find chemistry slightly difficult. Yeah, why? Because in chemistry there are some things you gotta sit down and memorize. There are some things you gotta sit down and understand, and there are some things you gotta sit down and practice. Yeah, memorizing, understanding, and practicing. Yeah, these three areas in chemistry if you want to be successful. Okay, but anyway, so how do the products of this reaction show that this is an example of thermal cracking? Now, thermal cracking, the hint is in the name, is to do with heat. Right? And from your memory work, where you sat down and you memorized, these aspects, yeah, is you should know that thermal cracking gives you lots of alkenes, okay, as opposed to the catalytic cracking, yeah, which gives you lots of branch chains, okay, or aromatic hydrocarbons, okay. But this is thermal cracking, and the fact that you're getting lots of alkenes shows you that this is thermal cracking, even if they hadn't told you. So how do the products of the reaction part C show that the reaction is an example of a thermal cracking? Well, because the products are majority or mainly alkenes. So they're mainly alkenes. That's why I know it's a thermal cracking.